Okay, so this evening's video is Chapter 4, Section 4 on translations. We're going to find out how translations are related to reflections. And what you're supposed to do is you're supposed to watch this video and take your Cornell notes. And then once you complete your Cornell notes, you're supposed to do problems 2 through 7 on page 207. It might help you to have your book open while you're watching this video, and remember you can always pause the video or you can rewind the video to go back and get something that you might have missed the first time. Alright, so here are some questions that we're going to answer today. Number 1, what is a translation? What is a composite of reflections? What information do we need to have to complete a transformation? What does the two-reflection theorem for translations tell us? And what does this symbolism right here mean? Okay, so the first, what is a translation? The first thing we're going to look at is here I have my pre-image right here, my quadrilateral ABCD. And a translation can be looked at as a reflection over a set of parallel lines. Now, up until now, when you've talked about a translation, you've called it a slide and you just moved it a certain distance along a line. Where we're going to do a little bit different, we're going to reflect it twice over parallel lines. So we took this quadrilateral, I first reflected it over this line, which was line N, and then after I reflected it over this line, which is line M, I ended up with my translation. So if you look, it seems as though I took this and I slid it down here. So that's why it's like a slide, but instead of just doing a slide, I'm reflecting it twice. This is called a composite of reflections because I did two reflections to get my final image. It's one transformation followed by another. So I reflected over N and then I reflected over M. So that's what a composite of reflections is when I put two transformations together, and in this case I put two reflections together. Okay, so what do we need to know to complete a transformation? The first thing we need to know is direction, and the second thing we need to know is distance. And so here we have the same reflection that we had, or the same translation that we had before, where we reflected it twice. The two-reflection theorem for translations gives us not only, it tells us what the distance is going to be. So to figure out this distance here, all I had to do was measure the distance between the two parallel lines, and then once I measured the distance between two parallel lines, so let's say in this case the distance is 5, my entire slide is going to be a slide of 10. So I double this 5, and that would tell me the distance that the entire translation is going to take. So the distance of a translation is twice the distance between the two parallel lines, and that's what the two-reflection theorem for translation tells us, that if we measure this distance and double it, that's how far we're going to slide it. So the second thing we need to know is what direction are we going to slide it. And that's where this symbolism right here comes in. Whenever we're looking at this, if you looked at my picture from before, I told you I reflected it over line N, and then after I reflected it over N, I reflected it over M. So, looking at this tells me that this symbol right here means composite. This little open circle means that I'm putting this reflection together with this reflection. Now in this case it says the only thing that I'm reflecting is point E. Something a little unusual about the way you read this is you start with the end and then you work backwards to figure out your reflection. So I would start here with my pre-image. I first reflected over N and then reflected over M. So it seems backwards from the normal way we would look at it. So I start with this pre-image and then I work backwards. So reflecting it over line N, and then after I reflected it over line N, then reflected over line M. This is the one place where people make a lot of errors. They try to reflect it over M first, but if you just think about, this is where I need to start. I'm starting with my pre-image and then I work backwards. And that will help you figure out which direction to go. So as I said, the two things you need are distance, which the distance tells you between the two parallel lines, and then direction. This tells you what directions to go. I'm going to reflect it over N and then over M. Okay, so that's all of our notes and explanations for today. What you need to do now is open your textbook to page 207, and you need to do problems 2 through 7 on page 207.